The paper is Iron File Systems. The paper presents the design, implementation, and evaluation of a prototype iron file system, Linux IXT3, showing that the techniques such as in-disk checksumming, replication, and parity greatly enhance file system robustness while incurring minimal time and space overheads. The paper suggests a new fail-partial failure model for disks, which incorporates realistic localized faults such as latent sector errors and block corruption. Paper then develops and applies a novel failure policy fingerprinting framework to investigate how commodity file systems react to a range of more realistic disk failures. It classifies their failure policies in a new taxonomy that measures their internal robustness, hence the name iron, which includes both failure detection and recovery techniques. Paper shows that commodity file systems failure policies are often inconsistent, sometimes buggy, and generally inadequate in their ability to recover from partial disk failures. The paper uses 4 standard file system benchmarks: SSH build, which unpacks and compiles the SSH source distribution; web server benchmark, which responds to a set of static HTTP GET requests; postmark, which emulates file system traffic of an email server; and TPC-B, which runs a series of debit-credit transactions against a simple database. Looking at the contributions, the paper defines a more realistic failure model for modern disks, that is the fail-partial model. It formalizes the techniques to detect and recover from disk errors under iron taxonomy. It develops a fingerprinting framework to determine the failure policy of file system. It analyzes 4 popular commodity file systems to discover how they handle disk errors. It also builds a prototype version of an iron file system and analyzes its robustness to disk failures and its performance characteristics.